We now want to look at the meaning of that. Okay? We say that this is the equivalent symbol, which means when I say A, that means A is equivalent to B. The equivalence means implication in both sides, which means when you say A is equivalent to B, that can be interpreted to mean A implies B and B implies A. First, let's look at the truth table for this implication side. Say, for example, I have two objects, A and B. When I say A implies B, what exactly am I saying? I'm saying if A, then B, right? But now let's look at the truth table for this. True implies true. That can only make sense. That's true. But can anything that's true imply something that's false? No. We have a false thing, right? Then we have something that is false. In general, it can imply anything. If anything is false, it can imply anything after that. Which means, if something is false, can it imply anything that's true? Absolutely yes. So that is a true. Something that's false, can it imply something false? Of course yes. That is also true. Which means we realize that when we have this symbol and we have two things, the only time that is false is when A is true, then B cannot be false, right? But any time that A is false, we don't care really what B is. B can be true, B can be false. Which means it's correct for you to say a false statement can imply something false. Okay. Now we move to something that is this. This symbol is basically interpreted if and only if. That is, if we say A is equivalent to B, right? Then we have A implies B, and at the same time, B implies A. As you can see, we have the double arrows there. The same. Now, this also means that A and B are equivalent statements, which is why we call it the equivalent symbols. What does that mean? We're saying that if A is true, it implies that B is true. But also, whenever B is true, A is true. So let's summarize this in a truth table. So suppose A is true, B is true, then A implies true. True implies true. True implies true. That is correct, right? Suppose now A is true, B is false, right? Then we have true implies false. That cannot happen. And as much as this will not say to us false implies true. That can hold, but this part will not hold. Therefore, we fail to have equivalence, right? So this is false, right? Think about it the other way. A is false, B is true. This can happen because this false can imply true, but true cannot imply false. Therefore, it ends up being false here, right? Suppose they are both false. A implies false. That's true. False implies false. That's okay. False implies false. That's okay again. So that will give us a true there. Therefore, the truth table of this is that this can only be true if and only if they assume the same state at the same time. Now, let's look at this following example that will include everything that we know so far about all the quantifiers, the implication, the equivalence, right? So this statement is saying to us, for all x, there exists a y such that all of that, right? Now let's look at what this whole expression says. It says, for all x, there exists a y such that x equal to y plus 2. If x is equal to y plus 2, then if x is equal to 3, then y should equal to 1. Or if y is equal to 1, then x should equal to 3, right? That's that part. Or in other words, y will equal 1 if and only if x equals 3. Let's begin by choosing any x right? We have an arbitrary. This statement says that if this, then that, right? If you want this whole expression to be true, we now look at the different instances when we have truth coming from the truth table of this implication, right? And we discovered earlier that this whole expression is true either when, first, this is true, that is true. Second, this is false, this is false. This is false, this is true. To show that there exists a y such that this part is true, then that part will also be true. And in this particular case, our y will be such a y that is equivalent to x minus 2 for any x that we choose, right? Then for this to be true, if this is the case, then that has to hold, right? This is now saying that y is equal to 1 if and only if x is equal to 1. But now let's think about it. We have a y that is equivalent to x minus 2. If we make this 1, this can never be 1. This is 4. Right? We now have something that is true here, but then the implication is not true. And from this, we know that this whole thing then fails to be true. Because we have something that is true, implying something that is false. Overall, the whole statement is false. Let's look for the second case. Now, we want to think about this is false. What happens then? Right? If this is false, y doesn't have this format. Right? There is some y somewhere. Right? The first part says x is equal to y plus 2 if that x was just arbitrary and it doesn't have the form where y is equal to x minus 2. This is false, right? No matter what this is, false will always be true. This could be true.